Our last presenter is Ronnie Medlock from High Steel. Please welcome Ronnie.
So I'm with High Steel. We're a bridge fabricator right down the road, about 40 minutes from here. We do steel bridge girders like the one that Melissa was showing. We do about 150 bridges a year, so we get quite involved with weathering steel. Maybe between a third and a half, depending on the year, of the bridges we do are done in weathering steel. So a little history. Weathering steel is probably not new to any of you. It's been around a long time. You probably hear about it a lot. Originally it started with U.S. Steel. They were looking to make a stronger steel with higher tensile strength, and so they added alloys, and they got there. But they also discovered that the steel they had produced had higher or better corrosion properties, adding copper, chromium, etc. Produced this oxide layer, also known as a patina, that once it forms, it precludes further rusting. So, very nice performance. Obvious benefits of that, the economy is there, no shot painting, or maybe just end paints, and also in the field. You never have a coating to maintain. I'm in a lot of conversations with engineers these days about their durability solution. And a key thing is they don't want to go out and have to maintain the coating, which makes sense. It's costly and it disrupts traffic, as you guys well know. No coating to maintain if you use weathering steel. But you have to be careful. There are certain things you've got to do to make sure it performs well, and I'll talk about those a little bit more. It's also very aesthetic. Of course, that may be a matter of opinion. I personally like it. I think it gives you a really nice color. I took this picture in Shepherdstown last year. Shepherdstown, West Virginia. You see the Haunch Girder Bridge over the Potomac. Very nice color. And of course, no coating to maintain. And then there's the Loop 360 Bridge in Austin. That's Austin Country Club there in the back. If you watch golf, you'll have seen the World Championships a few weeks ago. Sometimes see the bridge in the back. Once again, very aesthetic. Do note, though, you see some staining along the bridge rail there. And so that is something that you need to be careful to, or you might want to be careful to control if you use weathering steel. And I'll talk about that a little bit more too. So FHWA issued a advisory in 1989. Michigan had some problems with their weathering steel bridges and had put a moratorium on their bridges, and concerns were being raised, and so they did a study and issued a policy, or I guess recommendations, you would say, on how to use weathering steel. This is still their practice in effect. You can find it online. They are updating it. I talked with Justin Osell, who's been working on that. He doesn't have a timeline, maybe in the next couple of years. These are some of the key things that they recommend. Be careful about coastal areas, marine coastal areas, areas of frequent rainfall, etc., industrial areas. And actually, the industrial areas is one of the things that will come off of the recommendations, both with changes in industry and lack of acid rain and recent studies that show how weathering steel performs. That's considered no longer a concern. I mentioned Justin is updating the recommendations. He's had work done at University of Delaware by Dr. Jennifer McConnell, and she affirms that. She says, there's not a reason these days to include that in the recommendations. So that will change. So from the fabrication standpoint, once again, kind of obvious, it saves time and money in terms of compared to coatings. When we do a weathering steel bridge, we will blast clean the fascia girders. That is a very good idea. And I'll mention that again. I'll show you a couple of pictures of why you want to do that. We, as well as any bridge fabricator these days, has what we call a blast cabinet. You see it in the picture there. To clean a fascia girder, you only need a SP6, which is not like a near white, like when you paint. So typically one or at the most two passes through this cabinet will give you the cleaning that you need for weathering steel. Paint, however, you will do that same blasting. You're looking at a SP10. It takes a little longer. Might take a little bit more passes through the machine, so there's a little more time in the cleaning. Certainly there's more time in the painting. Typically we do 3 coats in the shop. If you're in the Northeast, you'll do all 3 coats in the shop. If you're in the Middle Atlantic, further south, you may or may not. In the South, you usually do prime only in the shop and then field paint for the top coats. Curing time can be an issue in terms of the schedule. When we paint, if we use organic primer, then the intermediate can go on immediately, as can the top coat. But if we use inorganic primer, inorganic has to cure with moisture, so you can't put the second coat on until the first coat is cured. So we'll wait a shift or a day, depending, until we get the hardness of the IOZ to tell us that it's cured. It depends on the temperature and the moisture conditions. In the winter, if we're doing IOZ, we pump moisture into the shop to make sure that primer cures. It's doable, but compared to weathering steel, it does add time. Compared to metallizing, once again, you're cleaning. Metallizing requires a very significant cleaning. Metallizing, which is thermally sprayed on zinc, requires a deeper anchor pattern than paint. And so for metallizing, we'll first pass the girders through the blast cabinet, but then move them to another bay and then hand blast. So there's a lot of cost and time in cleaning for metallizing. And then the metallizing application takes longer than paint. It's worth noting the difference in the application. If you look at the top right, you'll see a painter. Bottom right, you'll see a metallizer. Significant difference in that gun, right? Look at the size. The metallizing gun has got the zinc wire feeding to it and also a current, because we use an arc to melt the zinc plus air. So you're spraying on with air, you're melting the wire with an arc, and you're delivering the zinc. So there's a lot of stuff to come together in that gun. It's a rather heavy gun. And you see the size of it. So it's well suited to large spaces, but not small ones. So a key thing that we recommend at High Steel is don't metallize the small stuff. Metallizing has become popular, and some folks look at it as it's a way to get galvanizing on bigger stuff. Galvanizing is a really excellent coating. You can't galvanize stuff that is too big for the kettles. So metallizing is kind of caught on as, oh, well, it's like sprayed on galvanizing. In a way it is, because it is sprayed on zinc, but it's nothing like galvanizing in terms of how the coating is formed. Galvanizing forms by interacting with the iron in the steel to produce grains that grow off the surface versus spraying on zinc. Metallizing is a good coating, but to try to say it's the same as galvanizing, really it's not. Regardless, it's a good coating, and there's a fair amount of it these days, and it's popular, so we've brought that in, and we do that in-house. But it does take time and that cost compared to weathering steel and compared to paint. Talking a little bit more about galvanizing, once again, compared to weatherizing, there's additional time and cost. We do that same cleaning at our shop. When we do bigger pieces like beams and girders, we like to pre-blast because it gives us a better and a more uniform look and feel. We don't feel it's necessary on smaller stuff like cross frames, etc., but we will do that. Then we'll ship to the galvanizer. You see a girder here on the bottom left ready to go. Not a big deal, fair amount of time making sure we get it loaded on the truck properly and then shipping it there, getting in the galvanizer schedule. Galvanizer works it in through their practice, gets it back to us. All of those things add some time, not a huge amount of time to the project, but then also cost. A key thing here, it's not really about weathering steel, but I want to emphasize it. If you're looking at these coating solutions, again, we strongly recommend, if you're metallizing, to galvanize the smaller components. So for example, on this bridge on the top right, that's the K Bridge in New York City. We did 2 bridges there, cable stay bridge. Originally the plans called for metallizing, but consider metallizing that anchor assembly, you know, trying to get that big gun that I showed you in and around all of those corners. You can do it, and we do, but compare that to dropping that anchor assembly into a kettle, right? The galvanizing will cover everything readily and completely. You know, you look up inside that corner, certainly an important component of the assembly, a possible area where water could accumulate maybe and give you a durability problem. You certainly want to make sure you have a good coating there. You know, I just really, my opinion, our opinion, you just really don't want to try to metallize something like that when you can galvanize it so readily. Similarly with these cross frames, when we do a metallizing job, we'll always write an RFI and say, can we do the cross frames with galvanizing? And probably 90% of the time that comes back yes. It just makes so much more sense. In this particular job, the answer was no. The engineer felt metallizing was better, and it was in the contract, so you know that was fine. But you look at those back-to-back angles on that cross frame, and you think about, well, how would you get metallizing on all of those surfaces? So to metallize those, we first had to do the backs of the angles that were to be assembled, then make the cross frame, come back and do the cleaning and do the metallizing. So you'll notice there's some red in between those angles. That was to protect the metallizing that's already on the inside of those angles. Once again, doable. Gosh, lots of time and cost to metallize those cross frames. Back-to-back angles made it harder. Usually you don't get that. But regardless, a cross frame goes into a kettle so easily. So strong recommendation from us. Similarly, on this bridge on the bottom right, this is a bridge in our shop right now, the Raritan Bridge in New Jersey. It's a New Jersey Transit Bridge. That project required metallizing. We asked to galvanize the cross frames, so you see them. Here's the girder on the bottom right, and then the cross frame next to it. It's been galvanized. And then also you see in the bottom of the girder, you can see some tabs, looks like tabs, gusset plates for lateral bracing attachments. Those are all galvanized. So really much better practice on a large metallized bridge. Galvanize the small stuff. In terms of the impact, also there's always the schedule to think about. How much does it count? This is a typical schedule, I would say, for a smaller bridge, maybe a smaller grade separation. How soon can you get steel? Maybe 9 months. 9 months is a pretty good number. These days, that's about where we're at. We can be aggressive and be at 6. It may take a little longer. It depends on our schedule. But 9 months is historical, typical. If you look at the schedule, and if you look on the bottom right, you see fabrication. We're starting in mid-August and wrapping up in September. So it'll take us about 3 weeks to do the actual fab on this job. But it takes 9 months for all the work up front. Melissa was talking about getting the shop drawings back with us on that bridge, that emergency replacement. You look in this schedule, we've got 2 months for drawing preparation, and that includes the cycle for going through and then, another 2 months we've got booked for drawing approval. So that drawing approval is a critical part of the schedule. We always make assumption about how long it's going to take to get the shop drawings back. Assuming 2 months is pretty decent. Usually you get 2 or 3 weeks. You might get 5 or 6. You might get 5 or 6 months. It's out of our control. That's unusual, but it happens. And think about what happens to your schedule if you're not getting your shop drawings back. So that's another important thing. But certainly something to book. Associated with that is getting the material. You'll see a line there for material procurement. It takes us about 10 to 12 weeks to get material, so that's not bad. If a contractor has given us a job and he's going to be working on the substructure and then we're going to be delivering the steel about a year later, that kind of procurement isn't a problem. But if you want to do something on an emergency basis like Melissa was talking about and you want a girder in a month, we can do that too. I know of a couple of jobs we deliver girders in about 3 weeks. And what we do there is we use the material that we already have on the ground. We talk to the designer and work very closely, say, here's what we got. Is this going to work for you? And you can make things go on an emergency basis lots faster. A couple, 3 weeks is really not undoable. But 9 months is probably typical. In terms of weathering steel, then, if you look at the schedule down here, main fab is there in August. I've got cleaning and painting in September. So once again, about the same amount of time to clean and paint that it took to do the actual fab. If you're using weathering steel, then that time goes away. Now, how much does that matter? Again, if we can do a bridge in 9 months and the contractor needs it in a year, it's not saving any time that's critical. But there are times when the schedule is critical for cleaning and painting. And of course, here I've showed you a job that would take about a few weeks to do. But the bigger you get in terms of the members, the longer that takes. And that could have a significant impact on your schedule. Just as one more example, we did the Tappan Z replacement. Those were 12-foot deep girders. Just cleaning those girders took 8 hours, took a whole shift just to clean them. So the cycle time can really go up. And so when you're thinking about your schedule, if you've got a big job and it's schedule critical, that's an area where weathering steel certainly could help you. In terms of cost, then, I've given you some factors in terms of the kind of things that would impact cost. We did a comparison back in 2017 to say, all right, how much more do the coating solutions cost? So we took this typical bridge and we estimated it as delivered weathering steel bridge. And then we compared it with other solutions, 2-span bridge, 99 frames, 10 girder lines, pretty typical smallish steel bridge. So we looked at these strategies, and what we found was if you painted that bridge, that increased the cost about 24%. If you galvanized it, that increased it 41, metallized it 42, or 50 CR, which we had just done a 50 CR bridge for Virginia. That increased it by 130%. DCR or A1010 bridge is a steel with about 11% chromium. So that's sort of a poor man's stainless. So it's rather expensive on the material side. So those are your comparisons. Emphasizing your metallizing, first of all, we said if sealed, then 49. And at the time we did this study, there was a kind of a blend of whether or not the metallizing is sealed. These days, almost everything we get is sealed. So that's probably closer to that number. And the metallizing number assumes that you galvanize across frames. If you metallize across frames, then that number jumps to 57%. And then, of course, I've already explained why that could be a factor. In terms of galvanizing, if you add fascia paint, 54%. So we sometimes see that. So this gives you a rough idea of the cost. Now, again, this is the cost of the fabricated steel delivered to the site. It's not the cost of the whole bridge, of course. It's just one component of the steel. But certainly, weathering steel can save you a significant amount of money as well as schedule on your project. So how well does it perform? That's the question. Well, it's great. It sounds great, Ronnie. It's cheaper, but how's it going to do out there? There's been some mixed performance, generally pretty good, and I'll go through that. First, there's a study here done by Texas DOT. I was with Texas DOT about 20 years, and while I was there, we often got into discussions about, well, how well does weathering steel perform? Because there were the proponents that said this is great stuff. There were others who said, well, we're getting these stains, and so that tells us that it's still rusting away. This is a problem. And some of us said, well, yeah, but those stains are the initial. And so if you look here, we painted a pier. There's a little white square. Said, all right, let's put some white paint. And then we saw, oh, I guess it really actually still is staining. So, all right, let's do something a little more formal. We studied the bridges in the state. I think we looked at 30 bridges to see how well they performed. First, we did a little survey of the districts. How well do you like it, and would you use it? Most of them were pretty in favor, but some of them were anti. So this is what we saw. Fundamentally, in terms of performance, we saw no durability problems with any of the Texas bridges. We looked at 30. There were 2 over salt water. The two that were over salt, really brackish water, had formed the patina. The other bridges we looked at had not formed a patina yet. It was actually a very slow process. This includes in Houston, which gets a lot of rain. Of course, we do have good wet-dry cycles. One of the concerns is mill scale, and that was, if you looked at the district responses, one of them was, we don't like it because of mill scale. And certainly it is rather unsightly. This top left picture, if you don't take the mill scale off, it could be there 20, 30 years. So it's not going anywhere. There was a requirement in the TxDOT specs that the mill scale be removed, but contractors, what we found out in doing the study, contractors would say, hey, we'll do that in the field instead of the shop, and that would get okayed. And then when the steel got to the shop, the contractors would say, well, we can't do that, we can't blast out here. And so they kind of got around it, unfortunately. So there were some bridges that were built with a mill scale, and it gets, if you leave it on there, it really looks bad. But as I showed you, fascia girder at our shop, one pass through the blast cabinet, it would take that off without any problem. You have to make sure you clean your marks off. Now this bridge on the bottom left is in the shop yet, but if you were to get the steel out there with markings on it, the typical shop marks, then you would be able to see those. And down in the picture in the middle, you see a drip plate, also called a drip bar. Those are very good for diverting water away from piers to help control staining, but they're supposed to be at an angle. So we saw some cases where they were square, and if they're square, they'll trap debris and moisture and be a durability problem. So you want to use them for your stain control, but you need to be careful to put them at an angle. Similarly, in the top in the middle, we found that drip pans work very well. So if you look there, you see a pier cap that's out exposed to the elements, gets a lot of rain, gets a lot of cycles, but the drip pan does a good job of keeping the stains off the concrete. And it doesn't go very far past the edges of that concrete, so they work very effectively. But again, you've got to be careful about ponding. We also looked at this bearing on the right, which is a bearing for a railroad bridge. Railroad bridge, CSX over Interstate 10 in Houston. And we saw stains coming off there, so we went up and looked, And what we saw, if you look in that top right, you can see there's water in between the stiffeners. And so there are weep holes at the bottom of the stiffeners, but in the middle picture you can see they're plugged with grime. So the grime plugs the weep hole, the water collects in there, and then you got a big durability problem, right? If you look in the bottom right, that's how they're supposed to look. You know, if the weep holes are open and there's not debris collecting there, then you'll be fine. So use a bigger weep hole, etc. If you want to use weathering steel, it'll be effective, but make sure that it's not ponding. So TechSoc conclusions were, yeah, it performs very well. There weren't any concerns with long-term durability, but there were better controls for stain, etc. Going on to Maryland. Maryland had a problem with some of their bridges over I-70. If there's anyone from Maryland here, maybe you'll recognize this. Very heavy salt accumulation on these bridges. If you look here, you'll see the salt accumulation. You'll see some of the weathering steel that was continuing to flake off. So they were not getting that patina and not getting that control. Significant problem. Virginia had a similar problem with a bridge near Washington, D.C. Tunnel-like conditions, lots of spray, over 200,000 cars a day. You think about Washington, D.C., you know, certainly you get that kind of traffic. And continually getting salt. They had a sheet of web that came into traffic. So significant problem. So you have to be very careful of situations like that. Virginia has adapted their policy for use of weathering steel. Maryland has now got a moratorium. They will only use weathering steel over railroads. Again, it's very effective, but be careful how you use it, certainly. Iowa did a study of their bridges in 2013. West Virginia Elsinore did this study, and they came back and said, yeah, salt accumulation can be a problem, and so they came up with these recommendations for washing. Depending on the structure type, whether it's a grade separation, interstate below, local load below, or stream crossing, urban, suburban, rural, with different priority. Once again, if they have a bridge, or the recommendation was if they have a bridge in an urban area with high traffic, be sure to clean it every year. Otherwise, salt will accumulate and potentially give you that durability problem. I found this, I remember this study from Norm Macdonald years ago, and I went and found it while I was preparing. I know these were recommendations. I don't know what Iowa actually went and implemented, but they certainly sound. So finally, Connecticut study. Connecticut just completed this last year, once again wanting to go out and look at how well are their weathering steel bridges performing. In Connecticut, weathering steel is the first choice, given the economic advantages, upfront cost, and in-service cost. Eliminates painting and painting maintenance. But so they wanted to go out and see, well, how's it doing? They looked at 3 sources of corrosion: environment, in other words, proximity to salt water, vehicles, spray from trucks and trains, and also details, leaking joints. They looked at 138 bridges in Connecticut, weathering steel bridges. Their policy, first of all, aligns pretty closely with that tech advisory, except if they are near vehicular spray or salt water, they'll increase their flange thickness. They also paint the inside of boxes, both for protection and inspection. I think that's pretty common. We paint the inside of a lot of boxes. I know when I was at Texas DOT, we did the same, just to facilitate inspection. Put a nice white coating in there so you can do your inspection. And also eliminate deck joints wherever possible. Now that's newer from about 20 years ago. So here's the results of their study. They looked at various bridges, and the key thing they found was if there is leaking on the bridge, that has a significant impact on the performance. Of the bridges in the study, 98 on the left of them had leaking, 40 on the right with no leaking, much better performance. These numbers are ratings. So you have some 5s, which are the dark orange, and 6s, which are the lighter orange, on the leaking side. On the bridges without leaking, nothing worse than a 7. So good first indication. Looking at section loss associated with leaking and the age of the bridge, each of these bars is a 10-year increment. 10 year, 10 to 20, etc. The last bar over is 50 years. If the group on the left is no leaking, bridges with leaking, you start to see some numbers. These are section loss. So that yellow is 3/16, quarter inch for the orange. The dark brown at the top on the right is 3/8. They show a half on the scale, but they didn't get anything as much as a half. So as the bridge gets older, If it's leaking, they start to see section loss. There is one bridge over 50 that's doing well, but it is just one bridge. Looking at traffic, they said, well, does traffic make a difference? They split the population in half, found that about half were over 5,000, half were under. So they said, all right, high volume would be over 5 and trucks, 5,000 trucks a day, and under would be less than 5,000. So once again, on this left side, your left, no leaking and not a significant number difference on the traffic, which is very interesting considering Maryland and Virginia's experience. Of course, those are perhaps much higher traffic than you might get in urban Connecticut. Regardless, there are 26 bridges under 5,000, 20 over 5,000 a day, and they didn't see a significant difference in traffic. But they did notice on the bridges on the right where you're leaking, you do have that problem. Water crossings, again, it didn't seem to make a significant difference, except that the leak, there was a correlation with the bridges that leak. Their recommendations from the research in Connecticut has adopted this. They're going to continue with their policy. They're first using weathering steel for the economic savings, using it unless it's precluded by environmental local conditions, and of course don't use joints. If bridge is leaking, for existing bridges, paint at the joint, or where they have the slab to back of back wall was used, they noticed that was a common leaking detail that they used to use. They said go back and paint those. So in conclusion, on the one hand, an extraordinary value. If you look at that first cost bridge, for a typical bridge, much cheaper, a lot of savings compared to painting, galvanizing and metallizing, both in terms of cost and schedule, and also certainly in terms of coating maintenance. You guys would be more familiar than I would in terms of the associated costs with maintaining coatings in the field. So that's there. But detailing is important. You want to make sure there's no leaking on the bridge. If you're over high traffic with salt, be careful. From what I've seen, if I was in an area like urban DC, it had that tunnel-like condition, I certainly wouldn't use it. But there's plenty of other crossings that do make sense. And from the aesthetic standpoints, do be sure to remove the mill scale and control substructure staining. You use those pans I showed you, drip bars. Also, during construction, cover the piers. This bridge here, you see the wrap of the pier until the bridge is open. Once you've got your deck in place, then it's covered and you won't get as much staining. That concludes my presentation. Any questions? Okay.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.